are going to get into the formal hypothesis testing framework. And we're going to use p-values, but I'm also going to introduce you to an alternative way to test hypotheses using some other parameters. The roadmap would be to start up with the prepare phase, where we would identify the parameter of interest. We'll list the hypotheses, namely the null and the alternative hypothesis. We'll identify the significance level and some other parameters that we're going to need in testing hypotheses of the null hypothesis versus the alternative hypothesis. Then we'll go on to the second stage where we'll learn how to check the underlying assumptions of the model. And then thirdly, we'll get into some calculations, namely the mechanics, and all of the results we have computed or obtained earlier will be used in the last step, namely drawing the conclusions. So to get started, we consider an example. It is believed that nearsightedness affects 8% of all children. In a random sample of 194 children, 21 are nearsighted. Conduct a formal statistical hypothesis test for the following question. Do this data, and by this data, that 21 out of 194 being nearsighted, does it provide evidence that the 8% value is inaccurate? We have been told to use a significance level of alpha equals 0.05. Remember, if you're not given this significance level explicitly, the default value is also 5%. Now, back to the question. The first step is to prepare. We would like to identify what population proportion is of interest to us. That is the percentage of all children who are affected by nearsightedness. That is clearly documented here. Now, regarding that value, is it a set value that we're sure of or not sure of? Well, we have decided to collect data from a random sample to check if that value is valid or if it has changed. In fact, we want to check if what the data provide evidence that the 8% value is inaccurate or different. So, to set up the null hypothesis, we have our P being the status quo, so which is 8%, versus the alternative hypothesis that we want to test. That is it inaccurate? That is the P different from 8%? Our alpha at this point is 0.05, the level of significance of the test. And then our sample proportion P at is X over N. That will be 21 out of 194 who are nearsighted. So, as it stands, what would 21 out of 194 represent? That represents about 0.108, 10.8% approximately. The next step is to do the model check. We check if the sample was randomly drawn, which appears to be the case. Then we look at the success condition, where we multiply the sample size, 194, multiplied by the null value. The null value in this case is 8%. This is the null value. So 194 multiplied by 8% or 0.08. 194 times 0.08, I have 15.52, which exceeds 10. We like that. So the failure would then be, since 15.52 goes to success out of 194, 194 minus 15.52, 194 minus 15.52, that would give us 178.48. That would be exactly similar, equal to the sample size times 1 minus the null value. This is also greater than 10. We like it. So with those conditions checking out, I want you to note that moving forward in later examples, we're not going to explicitly check these conditions anymore. We'll just assume that they hold. Now, with the next step, which is the fourth step, will be to find the value of the test statistic. That requires us to take the sample proportion and look at how far is it away from the assumed proportion, population proportion, aka the null value, and then divide that by the standard error and get what we call the computed z, or the z statistic, or the test statistic. Then we'll find the critical value and find the p-value. To do that, we're going to go to StatCrunch to help us with these computations. So let's go to StatCrunch. I'm going to do this, and close out of this. And let's find these values. You go to Stats, go to Proportion Stats, one sample, with summary, click on that. And then what is the number of successes? That is 21 out of 194. So 21 out of 194. Click on hypothesis test for P. What is the null value? Our null value here is 0.08. So 0.08. This will immediately update. Then what is the nature of the alternative? Not equal to. Make sure you choose intentionally not equal. And then the next step is show the critical value. I'd like to see that. You don't need to store in a data table. This should just be good. If you want an optional graph, which is the p-value plot, you're welcome to do that, and click on compute. On the first page of the returned output, I can zoom in a little bit here. Let me also do the same here. Good. You will find that we have the z stat value, which is 1.45. So I have 1.4502, and I have the critical value, which is approximately 1.96, and I also have the p-value, which is 0.147. So based on these facts, I can go back here and I can draw a conclusion. To draw a conclusion, it's a good time to remind ourselves that just before we started this exercise, we talked about the fact that we needed to get the computed z value, which I said I'll show you how to get, and I've just done that in StatCrunch, and then the p-value, and then the critical value, and we can use these values either using approach 1 or approach 2 to draw a conclusion based on this decision rule. So let me illustrate that in this example. So in this case, because the p-value which we got is 0.147 versus our alpha. Our alpha value is 0.05. Which one, so what's the relationship? Which one is bigger? Which one is smaller? Obviously, you have 0, 0, but 1 is greater than 0. So 0.147 is greater than 0.05. The decision rule says that if your p-value is greater than alpha, we should fail to reject the null hypothesis. Where is this from? Again, to remind us, that is on page 6, following the approach number 2. I'm going to show you that this is equivalent to following approach 1, where if the z stat is greater than the critical z, we should reject. Otherwise, if it is lesser, we should fail to reject. So in this case, let's look at our computed z statistic. You will notice that that is equal to the z stat is equal to 1.4502, 1.4502, and our critical value z was equal to 1.96. you will notice that 1, 1, 4 is lesser than 9. So the computed value of the z-stat is lesser than the critical value, which again should cause us to what? To fail to reject the null hypothesis. To reject the null hypothesis. And if we are failing to reject the null hypothesis, what does that tell us? It means that the winner of the null and the alternative hypothesis is the one we failed to reject. So that means this is the one we're going to decide on. But the alternative hypothesis has not been mentioned in this conclusion. So regarding the test hypothesis or the research hypothesis, which is the alternative, this means that there is not sufficient evidence. There is not sufficient evidence to state that what we wanted to test holds true, that the proportion is different from 8%. Let's take another example. In this example, we have the null hypothesis and the alternative hypothesis already given. So are we going to reject ultimately or fail to reject the null hypothesis? The parameter of interest, of course, is the population proportion. The null hypothesis has been given as P equals the null value. And the alternative is that P is greater than what? The alternative. This is a one-tailed test. We've been given our alpha to be 0.05, and our P at, our sample proportion, will be x over n, or 60 divided by 100. Okay? Which is same as 0.6. For our model check, we assume that the conditions we illustrate in the earlier example, 1, 2, 3, holds true. You're welcome to check that. And we can go into computing the mechanics to find the test statistic. So I'm going to go again back to StatCrunch. And in StatCrunch, I am simply going to go to Options and Edit. And to edit this, I will need to change this to 60 out of 100. And the null value this time is 0.50, 0.50. And the alternative, I have to make sure I indicate that it is greater than. And I would like to go again to compute. So let us see what that looks like. So in this case, my test statistic is my z-stat, which is 2. My critical value is 1.645 approximately. My p-value is 0.0228. With that said, I can go to my conclusion here. My p-value of 0.0228 compared to my alpha value 0.05 from here given in the question, I would notice that 0, 0, 0, 0, 0, but 2 is less than 5. When the p-value is lesser than alpha, we reject the null hypothesis in favor of the alternative, which means this time the null hypothesis lost and we have sufficient evidence for what we wanted to test in the alternative hypothesis. Take note that this is equivalent to saying that because the computed value of z, which is what? What was that value? 2. Compared to the critical value is 1.645. So let me write 1.645 here. Because this computed value is greater than the critical value, we are going to reject the null hypothesis in favor of the alternative. So that means that there is sufficient evidence to state that what we wanted to test holds true. Right. With that said, let's look at yet again another example. In this example, it says that in a survey, 45% of respondents stated that they talk to their pets on the telephone. A veterinarian believed this result to be too high. So, believed that this number is too high. So, it should be lesser than 45%. So, he randomly was selected 170 pet owners and discovered that 75 of them spoke to their pet on the telephone. Does the veterinarian have a right to be skeptical? Use the alpha equals 0.05 level of significance. Step 1, we prepare. What is the parameter of interest? That will be the population proportion of pet owners who speak to their pets on the phone. And regarding that parameter, the veterinarian believed this result to be too high. That is the claim that needs to be tested. That this proportion of those who speak is too high. That means it should be lesser than what? 45%. Versus the alternative that it is what? The status quo, which is 45% or more. Okay? So, for our model check, we assume that the conditions hold true and would like to proceed to the mechanics. But before we do, let's note that our alpha is equal to 0.05 and our sample proportion is x over n, or 75 who spoke to their pets on the phone out of what? 170. This is the sample data. And with that said, we can go back to StatCrunch and we're going to edit our entries. This time it is 75 out of 170, and the assumed proportion is 0.45, and we want to look at less than left tilde test. Okay, and would like to compute, and I'm going to do this and do this. Okay. In this case, we have the null and alternative hypothesis, and our z-stat value is negative 0.2312, and the critical value is negative 1.645, and the p-value is 0.4086. And with that said, let us use those numbers to draw a conclusion here. Okay, let's go here. We're going to go to the conclusion. Because the p-value is 0.4086, which is considerably large, compared to our alpha, the alpha value is 0.05. We can say that the p-value is bigger, significantly bigger, I mean reasonably bigger than the alpha value. So that means we fail to reject the null hypothesis according to the decision rule. This is equivalent to saying that because the computed value of z-stat is greater than let's make sure of that. Since we wanted to fail to reject, that will be less than the critical z. So we fail to reject the null hypothesis. And that's because, oh, I had it right above here. That's because the value of what z-stat is lesser than what? Is lesser than the critical z. Yes. So we conclude that if we're failing to reject the null this time, It means we do not have enough evidence for the hypothesis we really wanted to test. So that means we thus conclude that there is not sufficient evidence in favor of the alternative to state that our P, the proportion of pet owners who speak to their telephone on the who speak to their pet on the telephone is lesser than 45%. We do not have enough evidence from the sample data to indicate or conclude on this. Let's take another example. 20 years ago, 54% of parents of children in high school felt it was a serious problem that high school students were not being taught enough math and science. A recent survey found that 331 of 900 parents of children in high school felt it was a serious problem that high school students were not being taught enough math and science. Do parents feel differently today than they did 20 years ago? Use the alpha equals 1% level of significance. The parameter or characteristic of interest here will be the proportion of parents of high school students who felt that students are not being taught enough math and science. So regarding that proportion, what was the status quo? The status quo used to be that it was 54%. And currently, what is the current impression that we would like to test if it holds true today? A recent survey showed this data from the sample, and we want to check if parents feel differently than they did 20 years ago. That is, they feel that that proportion, P, has differed from 54%, either above or below. We assume that the model conditions are satisfied. We note that our alpha is given as 0.01 and our P hat is x over n, or from the sample 331 out of 900. 331 out of 900 felt that it was a serious problem that students were not being taught enough math and science. Okay, then let's go to StatCrunch yet again and use the facilities there to compute the values we need. So I'm going to edit this. I'll go and I'll key in 331 out of 900 just to be sure, just to bring us back on par. You can always go back to stats, go to proportion stats, go to one sample, go to width summary, and then key in the parameters. We want 331 out of 900, and our proportion here is 0.54, and we would like to look at less, not equal to this time. So not equal to is good, and then I would like to show the critical value and compute. So my test statistic value is negative 10.36654. The critical value is 1.96, and the p-value is so small that it is smaller than 0.001. So based on that, I can take these values and draw a conclusion. My p-value is so small that it is less than 0.001, and compared to my alpha, which is 0.1, we can tell that the p-value is significantly, really lesser than alpha. And whenever that is the case, we reject the null hypothesis. Take note that when you're rejecting the null hypothesis, that is equivalent to saying that we reject the null hypothesis because the computed value of the z-stat is greater than the critical value. So if we are rejecting the null hypothesis, we are going in favor or concluding in favor of the alternative because we have sufficient evidence from the sample data to indicate so. So we thus conclude that there is there is sufficient evidence to state that P is what? Not equal to 54%, or that parents feel differently today than they did 20 years ago when it used to be 54%. So we have sufficient data to indicate that parents feel differently today than they did 20 years ago. All right, let's look at another final example in this regard before we talk about other aspects of hypothesis testing. In this example, we are told that 400 students were randomly sampled from a large university, and 282 said they did not get enough sleep. We are to conduct a hypothesis test to check whether this data provides or represents a statistically significant difference from 50%. We're required to use a significance level of 0.01. A gentle reminder too that if the significance level is not explicitly provided in a question, please use 5%. All right, back to the question. What parameter are we interested in? That would be the proportion of students at the large university who did not get enough sleep. So, population proportion of all students who are not getting enough sleep. In this case, you have, we're going to bring in our P. We want to see if it is different from 50%. So, status quo will be 50% or 0.50 versus what we want to test, which is that it is different from 50%. At alpha equals 0.01, okay, so I'm going to have my 0.01 there, and our P at is x over n. That will be 282 out of the total 400 students who were sampled. As usual, we're going to assume that conditions assumed to hold true. You're welcome to check that at your own time. Then we go to StatCrunch to help us compute the test statistic. So let's go to StatCrunch. Okay, let's do this. All right, here we go. And I'm simply going to close out of this, go to stats, go to proportion stats, one sample with summary. And we're going to key in the parameters here, which is 282 out of 400. And our assumed proportion is 0.50. That is the same as 0.5. If you like, you can adjust. What is the nature of our alternative? Not equal to, different from 50%. And in this case, we would like to show the critical value at 0.01. Okay, so 0.01, and we would like to compute this. Okay, so at 0.1, what do we have? We have the critical value, which is 8.2. So 8.2 is our z-stat value. Our critical value is 2.576, and the p-value is so small that it is smaller than 0.0001. Okay, and let's go back here. So what do we have? So because the p-value of which is significantly lesser than 0.01 is lesser than alpha, which is 0.01, we're going to again in this case reject what? The null hypothesis. So this is equivalent to saying that we are rejecting the null hypothesis because the computed value of the test statistic is greater than the critical value. So if we are rejecting the null hypothesis, in this case we are going in favor of the alternative, which we really wanted to test if we have sufficient data for, sufficient evidence for. We thus conclude that there is sufficient evidence to states that our P is not equal to what? 0.50. That is, that this represents a statistically significant difference from the 50% we got earlier. All right. Earlier I noticed that we had what? 0.05 in this question. I am not particularly sure if I did that, so I'm going to go ahead and look right back at that. Apologize for that. So let's see. Let me go to edit this. We had 331 out of 900. So 331 out of 900. I assumed that this was 0.05, but let me check. And our null hypothesis was 0.54, and the critical value is 0.01. Okay, and let's compute and let me see if I have the right values there. Okay, yes, so we have negative 10.36656 thereabouts. This is close, but the critical value should be 2.576. So my bad on that. So in this case, that would be the only thing that would be of critical change. Yes, 8. But the p-value is still 0. Is still lesser than 0.01. So because the p-value is less than alpha, all of the conclusion will still follow as previously established. All right, let's see. Okay, this was 0.05, and this was also 0.05. Okay, and this was also 0.05. So please be careful. If it is 0. If it is different from 0.05, you will need to change the significance level. So that brings us to the end of those exercises. In the next video, we're going to examine the types of statistical errors, namely type 1 error and